Hello and welcome to the AIM webinar series. My name is Mike Ellen and I serve AIM Inc. as their Member Engagement Manager. AIM is the trusted worldwide industry association for the automatic identification industry. For nearly half a century, AIM has provided unbiased information, educational resources, and standards to providers and users of these technologies. AIM membership provides access to an insider's perspective on trends and opportunities, along with a voice in shaping the growth and future of the industry. AIM member benefits include education, advocacy, and community, as well as a role in creating industry standards through collaboration. AIM is an investment in your future. Before the presentation starts, I would like to discuss with you a few housekeeping items. First, you will notice that you are muted throughout the presentation. Please do not use the raise hand option during this webinar presentation. If you have any questions during the webinar, please click the chat icon on the top right of your screen. After this, you'll see a chat dialog box at the bottom right of your screen. Make sure in the Send To box you select AIM Inc., and then in the box below type your question. We will try to answer as many questions as we can after the presentation. Today's presenters are Jonathan Skinow and Ben Jakubovic. Jonathan has over 10 years experience in the RFID safety and security field. He is an expert at developing elegant solutions to customer problems previously thought to be insoluble, and has been developing solutions for the utility sector, Fortune 500, manufacturing, schools, and airports. John will be discussing the application of new technologies to solve classic challenges in lone worker safety while enhancing enterprise-wide protection. Ben is a member of the National Safety Council and the ASIS Utilities Council subject matter expert on RFID. Ben will be fielding all attendees' questions regarding existing best practices as well as newly available solutions which dramatically enhance employee safety, mustering and evacuation speed and efficiency, as well as workplace violence and response. With that, Jonathan, take it away.
All right, thank you, Mike, and thank you for everyone attending. We'll start off by going over some terms, then current technologies, solutions for lone worker safety, and then finally moving into the latest cutting-edge technologies. So let's start with the terms. A lone worker does not need to be an employee. It can include outside contractors or visitors that are out of sight and earshot of any other person. RFID stands for radio frequency identification. It uses radio frequencies to transmit the identification of the person, item, or associated tag. EAP, or Emergency Action Plan, is a written document required by OSHA Standard 29 CFR 1910.38a. The purpose of an EAP is to facilitate and organize employer and employee actions during workplace emergencies. And finally, IC, or Incident Commander, is the person responsible for all aspects of an emergency response, including quickly developing incident objectives, managing all incident operations, application of resources, as well as responsibility for all persons involved. Now let's look at some challenges facing lone workers. The first major challenge is that people can have health emergencies such as heart attacks or strokes, leaving them incapable of signaling for help.
John, if I may, I'd just like to interrupt you for a moment. This is Ben Jakubovic, Jonathan's colleague. I'd like to speak to one of the most fascinating situations encountered as far as medical emergencies go. A few years back, a very large bottled water distributor lost track of one of their employees. He was listed as a missing person for 3 days until time came when a co-worker discovered his body laying between pallets of bottled water. An autopsy later determined that he had died of a heart attack. He may have had time to call for help, and nobody would have heard him as he was well out of earshot of other folks in this huge building. This is one of the inputs that prompted us to focus our efforts on not just security, which was our focus at the time, but the safety of individuals as well in enterprises. Thanks, John.
Great, good story, Ben. A simple trip can cause injury, but falling is not limited to stumbling over a curb. A person can fall off a ladder or even down a flight of stairs.
John, just a quick note is that in OSHA's list of top 10 hazards for 2017, falls made it to number 1 with a bullet. This is a very prevalent situation.
Oh, wow, that's a very good piece of knowledge there. A third challenge that I hate having to bring up, but unfortunately in today's society we need to discuss, workplace violence. Employees or visitors can bring weapons into your facility. There's a need to signal for help quickly and without the attacker knowing you sent for help. Lastly, when a bad actor is looking to gain entry into a facility, they're most likely not walking through the main gate. They're finding the understaffed areas, giving lone workers the best chance of seeing something, and they need the ability to send an alert quickly. Let's look at current RFID solutions on the market. The two main types of RFID are passive, which uses power from the reader to excite the badge and can only work over shorter distances, and active, which uses a battery inside the badge and is able to transmit information over a longer distance. Now let's look at some passive solutions. As everyone here is probably familiar with passive RFID, it's primarily used for access control. An employee simply places their badge in front of a reader to gain entry into a building. Guard tour works in a very similar fashion. However, readers are placed along their route, allowing supervisors to monitor the on-time completion of their route and not missing any checkpoints. Lastly, it is used in point reads. A portal is set up in entryways, allowing you to monitor when assets or people move from one location to another. Next, we'll be discussing the pros and cons of passive RFID. Some of the pros include the tags do not require batteries and have less components, giving them the ability to be smaller and more durable. The passive tags are also very inexpensive. On the other hand, with the tag being inexpensive, readers are generally much higher in cost. Since tags do not use batteries, it limits the read range from a few inches to around 30 feet. Because of the limited read range, your location is based on the last time the tag was scanned by either a portal or handheld reader and is not real-time information. Let's move on to active RFID. Some active RFID solutions have panic buttons built into the badges, allowing an employee or visitor to quickly and easily signal for help with their current real-time position. It also makes life easier. If you remember in the past, and some places still do it today, for gas coming into your home, meter readers would walk to everyone's meter, record how much gas was used onto a notepad. With active RFID, this is quickly accomplished by simply a truck driving by your home, and the information is automatically transmitted to the vehicle and uploaded directly to the customer's account. The fact that active RFID can transmit information means that you can attach any commercially available sensors such as CO2, available oxygen, light levels to name a few, and keep real-time information about the conditions in your facility. We spoke about guard tour with passive RFID. However, using active enables much more information, giving you the ability to not only monitor checkpoints, but know the real-time location of security staff and to ensure they took the full route, not taking any shortcuts to get to the next checkpoint.
John, if I could interject here, I just wanted to say that having active RFID as opposed to the passive for guard tours brings the solution into the realm of stopping something in progress rather than just looking at the past. With this system, supervisors have access to the real-time, minute-to-minute, second-to-second location of where all their guards are, so that in the event of an incident, they have a quick snapshot of who might be closest to where the incident took place and send the correct people with the right skills to deal with it.
Very good point, Ben. Thanks for bringing that up. Let's move on to the pros and cons of active RFID. As we mentioned before with active RFID, you have an almost limitless amount of sensor information that can be added to your system. It gives you the ability to fully cover large areas with fewer readers, and it works like a GPS system, giving the ability to triangulate the position of a tag within a few feet anywhere in the facility in real time. An active system is always expecting to hear from the tags, so if one is destroyed by a bad actor or even in an accident, once the signal is lost, it can trigger an alert in the system that there may be a problem. With active RFID, the reader prices are inexpensive. On the other hand, you can go to the next slide. Since the reader prices are low, the tag prices are more expensive because they need to have a battery inside and built to withstand hard drops inside of ruggedized housing to protect the components. Next slide will show the current lone worker solutions. Cell phones with a built-in panic button. This works great and gives you the location of the employee and the fact that they need help. But the big problem with this is, as I'm sure everyone here knows, when you need your cell phone the most, the battery dies. It's happened to me several times.
John, there's also the issue of cell phone coverage, of course, especially in rural areas. And I'd like to bring up the fact that they're reliant on GPS readings for the alert to have an accompanying location stamp. If the worker in distress is in a basement level or inside a big industrial building, very often they won't be able to get a GPS fix at all. There's another weakness.
Yeah, very true, and I do know the coverage can be a problem depending on what network you have. I know me and you have gone back and forth on who's better, Verizon or AT&T. The next technology, using a mechanical trigger, has been popular for fall detection on ladders. A pull tab is attached to the ladder. When an employee falls, the tab is pulled, alerting an emergency. The problem here is it requires the user to attach the tab, which is not always done, and does not detect falls, as sometimes the person can fall with the ladder and does not get far enough away to pull the tab. Check-in, check-out is an old technology that can be used with passive RFID, but the problem here is when one person swipes in, 5 people can follow, giving inaccurate information as to who is in your facility, or the bigger problem, when people leave, they easily forget to swipe out. Sometimes the check-in, check-out process is completed by security guards, but they can miss someone, or a lot of times an employee is just running out saying they'll be back in 5 minutes, so they might not mark them out. So this technology can leave you in a state that you may not know who is in or out of your facility during an emergency.
I wanted to point out, John, that this technology, if you can call it that, is very reliant on humans remembering to do it. You and I have been at locations such as construction sites and mines where the check-in, check-out is handled by people physically taking a hard hat off a pegboard and putting it on their heads. This is easily bypassed if they're running out for a quick lunch. It is not something you can rely on for life safety.
Very true, and it's not, and a lot of times people just simply forget. They don't, it's just a mistake that they forgot to grab something.
True, very true.
The last one here, I know very well as a firefighter, we use it all the time. When activated, it watches for loss of motion. As soon as it goes motionless, it triggers a loud siren for people to find you. The problem here, when you're in a loud facility, it can be difficult to find the source of the noise to locate an individual, and they have to be within earshot of the incident. Let's take a look at some cutting-edge technologies on the next slide. IoT, or Internet of Things, is basically having many devices communicating with one another over a network without human interaction. This gives you the ability to place many sensors around your full facility, giving complete coverage. They can be placed almost anywhere, with smaller and smaller form factors, and some can even be battery or solar powered in case of limited access to power.
And John, I'd like to add that this small form factor has brought power demands way down. Certain sensors, which just 5 years ago required AC power, can now be battery powered for up to two years. It's an amazing advance.
Yeah, very true. It is remarkable the strides they're making, not only in battery capacity, but actual power usage of these components. So what happens when you combine IoT and RFID? Thank you. Together, these technologies lead to the most cutting-edge lone worker safety solutions on the market. You now have the ability to crowdsource incidents from multiple people, locations, sensors to determine the full nature and extent of the event.
John, I just want to point out one of the most advanced uses of crowdsourcing data on an event as it unfolds is that the incident commander, looking at the situation on his tablet, can see new alerts popping up on the screen, giving him an idea of where at the moment the source of the problem is located, whether it's a bad actor or something mechanical going wrong. If it's a bad actor running down a hallway, for instance, he can literally follow the new alerts lighting up in that direction and have a directional arrow showing which way the bad actor may be running.
Very true. Thank you, Ben. Users can define rules to act on incoming sensor readings and take actions based on the best practices and emergency action plans. Real-time information of all attached sensors and locations of all personnel and visitors is at your fingertips. Lone workers can signal for help, or alerts can go automatically if your sensors detect trouble. Let's talk about alerts. As you can see on this slide, is an alert issued for an employee that has taken a fall. In one screen, you have all the information you need, such as type of incident, the person that needs help, and the exact real-time location. This alert was sent out to the cell phone, but that is not always the best method to alert your safety security team. Different alerts call for different alerting means, such as text message, text to voice, pop up on a computer screen, or during more threatening events can even trigger strobe lights or sirens going off.
John, I want to point out that that's not just linked to the type of alert, but also linked to the job function of the person who's being alerted. For example, someone whose job entails them sitting in front of a computer monitor is best served with a screen pop to grab their attention, while another person working in an area with loud machinery would be best served by a visual prompt such as a strobe light going off.
Good point. The environment does have a lot to do with your alerting methods as well. The big question that people have is what happens when no one in the first group of people alerted responds? After a defined amount of time, the system will automatically expand the amount of people receiving the alert until someone takes ownership.
Yeah, I want to point out that if you've gone through one or two levels of escalation and no one has still answered, the best practice here is to have the alert go to local emergency services similar to 911, police, fire, ambulance.
Yeah, that is a good point. You can continue to escalate the system up if when no one in your facility responds, actually go to the level of first responders. So let's dig into the alerts on the next slide. In your emergency action plan, for every incident is a set of steps that incident commanders need to follow. Using IoT with RFID, some of these tasks can be automated. For instance, during a fire, all elevators need to be moved to the first floor and the doors opened. The ones that are not automated are easily presented to the incident commander in a simple list. They do not need to find the EAP books and locate the checklist, as everything is quickly presented to them. As most of you know, incidents can quickly change on the fly. Therefore, a need to react quickly is essential. Once items are checked in the system, depending on the responses, it automatically knows the current situation and is able to tailor the following steps to this exact incident.
John, I want to point out that based on the responses of the incident commander checking off boxes as to conditions that might be present, what started as a physical alert, say as a explosion or a ladder falling, can easily turn into a medical incident. And these sorts of systems can be designed to be flexible enough to go down both of those roads simultaneously.
It's very important, especially in terms of the time you have for an emergency.
Mm-hmm.
All right, let's move on to situational awareness. Having all of this information in front of an incident commander is extremely powerful. They can look at a picture of the entire facility, knowing the conditions and where everyone is, or zoom right into the room of the incident, looking only at that area.
I'd also like to point out, John, the lower left part of the screen, as you see it right now, contains a list of people who are located in the areas you're focusing on. Lists their name and also lists in the plain text what room they're in of which building. This allows an incident commander to know who has made it to the assembly points and who is still in a situation where they need help. Very precisely, and allows for the dispatch very quickly of help where it's needed.
Very true. And not only that, if you click on one of the names, their contact information is right there, so it's very easily to get a hold of anyone if you need to. So what happens after the incident? Reviewing the incident is very important, not only to check and make sure it was handled properly, but to ensure your EAP is using the best possible methods. In the past, we relied on people's memory and some scribbled notes taken during the event. Now everything is automatically saved from the time the alert went out to its closing. You can pull up the event, see the locations of everyone in the facility and where they went, know who the incident commander was, and all of the actions taken by all team members, with notes entered into the system, and finally how it was closed and the final steps taken to assure that the alert was over.
John, this leads to a very consistent method of reporting, which allows for easy incident analysis and will allow an enterprise to refine their best practices.
That is true, and reviewing events really does, it brings up a lot of different things and kind of brings up different ways of looking at how you're responding to the events.
Mm-hmm.
Now let's take a quick look at a video of an alert. All right. As you can see, here is a layout of a facility with everyone moving. Once an alert is issued, as you can see, it pops up on the screen, giving you all relevant information, including the person's contact information. This is the sort of view that is presented to the incident commander during an emergency.
John, I just want to point out, you can see it pretty clearly on this screen, just beneath the portrait of the person who's in trouble, there's a button labeled contact. It removes one other possible source of human error, that is a misdialing. All the incident commander would have to do is click on that button to be patched through to that employee's cell phone.
Yeah, it does make life very much easier for incident commanders and hopefully keeps the incident going as smooth as possible.
Mm-hmm.
All right. So I think that's about it. If there are any questions or comments, Mike, please leave them in the chat box.
Yeah, thank you, Jonathan and Ben, for that great presentation. And it does look like we've received a few questions. Guys, would you like to go over these now?
Certainly.
Yes.
Okay, first question I have, what about privacy? Obviously, that's a big concern. My employees won't be thrilled about Big Brother joining the crew.
Well, I'll take that one if I may. From the beginning, these systems can be designed to take into account privacy. A very popular configuration that I've seen is one requiring passwords from, say, a union shop steward plus someone from management to unlock access to historical logs. As far as privacy goes in real time for a lone worker safety system, it'll be few and far between that someone will object to being saved if the building's on fire, God forbid. So concerns can be addressed with clever programming.
Okay, great. Another question we received, my workforce spends a lot of time on the road in multiple company locations. Will they be protected at all while away from their home location?
John, you want to take this one?
Sure. Yes, you can, with the active RFID system, you can add in a vehicle-mounted reader to bring that protection, basically a bubble of protection along with you, giving you the fall detection, everything that comes with it. Easily, it can slip in and be charged right from the vehicle's battery and continue from there.
And I'll add that at remote locations, all the locations are woven into one with the help of cloud communication. So a multinational company with an employee from France appearing in California who presses their panic button will be served just as well as if they were back in Paris.
Okay, thank you. This next question kind of goes along with that. It's actually a two-part question. The first part of that is, what is the range for the passive RFID?
John?
The range for passive RFID is anywhere from a few inches to about 30 feet, depending on the tag, the reader, a few variables right like that.
Okay, and with that, depending on range, how can this be implemented to monitor their traveling employees across the country? Their employees are in various customer sites working alone.
All right, so we would typically use active RFID here. Active does have a range. Again, it depends on the system and some factors, but the range of active is between 50 and about 300 feet. So it gives you a much more extended area to work with. Since the badges themselves have power, it enables you to add in sensors such as accelerometers, barometers, all sorts of different things to help monitor the employees. You know, for instance, the accelerometer, we can use that to monitor when an employee falls. Things along that nature. If you're inside of a facility, you can use the barometer to tell when the person is climbing a ladder to make sure that he's wearing the correct safety equipment. Well, actually, I'm sorry, the question was more on the vehicle side. If your employee is traveling, there'd be a active RFID reader situated inside the vehicle, giving him a kind of a 300-foot bubble of protection around that vehicle. If he's going into remote areas, it can come through either the cell phone network, or you can actually link to the Iridium satellite network. That way you'd have, I think they have 99.9% global coverage. So that would be the solution there.
Okay. And a question we received is, can you please explain how the crowdsourcing works?
I'll take that one. Crowdsourcing can be accomplished in an automated way or in a manual way. We're working on an automated solution, but manually, an incident commander who has a live view of events unfolding in front of them can see where reports of new incidents are arising, along with the nature of those incidents. So what you're doing is using your knowledge base of customers or employees or visitors who you have within your facility to provide you with real-time knowledge of what's going on. Not firsthand, but certainly secondhand. It's a lot better than looking at a structure from the outside and trying to guess where the bad action is happening.
Okay, thank you for that. Another question we received, is there a lone worker safety checklist available?
The checklists are generally, when we set up a new enterprise, we take their emergency action plans and take a tear-out sheet, which many of you may be familiar with, and simply copy the actions that are supposed to be taken. Those that can be accomplished automatically, such as, for example, John mentioned sending elevators to the first floor or locking fire doors, for instance, are done automatically. Those that require a human being in the loop are put into the manual checklist portion of the response screen that the incident commander works with.
Okay, and another question we have received is, are you aware of OSHA's thoughts on automatic identification or RFID lone worker safety solutions?
OSHA's directives, as far as I'm familiar with, are results-oriented, as far as I can tell. They don't speak much to the technical means of accomplishing them. They speak of protecting employees and not how you should do it. I stand to be corrected on that, but I think I'm pretty current on the OSHA regulations.
And sort of going along with that, what are or are there any regulations worldwide on lone workers?
Oh, they're definitely spreading. I know the United Kingdom has some of the strictest ones in the world. Canada has adopted them. The United States has adopted them. I would be surprised if the EU hasn't adopted something very similar in general. Safety has been a growing concern, not just over the last few years, but over the last few decades. I'm sure all you experienced managers have seen it. And this set of technologies enabled by IoT and RFID takes a lot of the burden of day-to-day supervision of supervisors, checking equipment at scenes and so on, and allows automation. Really takes a tremendous load off, and also gives you a tremendous database to mine to determine what has been dangerous, what has worked, and what has not worked as far as protecting your workers.
Yeah, I don't think there's an international standard. A lot of countries have a few different regulations. I think the OSHA one is 1915.84. There's a lot of, I'm 85% that's the regulation for OSHA.
Okay, well, thank you for that. So going back to, the traveling lone workers, essentially, in order to monitor the traveling employees, would they need to have a reader in their vehicle and then a badge on their person?
That's correct. That's the same badge that they use in fixed facilities is worn in the vehicle. And the vehicle reader unit is a specialized one. Its front end, so to speak, takes in RFID signals just as one that's mounted in a building would take it in. But it also has an uplink section, which in urban areas is typically a cellular modem in effect, which takes the data back to your cloud. For rural areas or areas of poor coverage, there can be a hybrid unit that falls back on Iridium or Globalstar or Inmarsat, any one of a number of satellite systems out there.
Okay. And there are some no-brainers that should utilize lone worker safety checklists or equipment. Are officers, gas station attendants, teachers, cleaners considered lone workers? And if so, do you know if they have lone worker policies?
I would think a cleaner would be covered by OSHA regulations. Since you bring up the point of teachers, I mean, this is very much in everybody's minds these days with 23 school shootings this year so far and counting. An anticipated use for this system would put one of these panic button badges in every teacher's hands. That would be an excellent array of crowdsourced information for any incident that begins to develop. There's also automated IoT devices which monitor the direction and nearness of gunshots as they go off. So there's terrific solutions being formulated right now to leverage the teachers' ability as human monitors and to keep children safer and address the situation more quickly.
And not only that, but you can also, if every teacher has the panic button solution, we basically be able to escalate an alert. If one teacher hits it, then it's an alert in the classroom. It would go to the security guard. But if you're getting, 5 or 6 teachers hitting the button around the same time, that can automatically go out to the police department or something along that lines, because now there's something that most likely is going to be a real incident.
That's a very good point, John. We've designed this into other systems. We've seen it designed in other systems as well, where if there are multiple alerts, you should have, when we spoke about alerts escalating up the ladder, up to 911, if you have 5, 10 alerts going off simultaneously, you can skip the lower stages and go directly to 911 in a situation like that, or of course in the situation of a school shooting.
Okay, another question we received. What options are available for unions which restrict the tracking of employees outside of the employee initiating notification of an incident?
There's quite a few out there that you can have for the unions. So from some of the most privacy-minded, we could set up a system where there's no actual stored tracking history. It's only during an emergency event. If someone hits their panic button, it begins tracking that person, saying, okay, I need help, this is where I am. Or, so during an emergency event, that's when it triggers, which is when you want to find people during an emergency. The other end of the spectrum is that you can basically lock out any tracking from being viewed unless a member of the union is present and signs in, and a manager signs in at the same time.
I'll point out one further scenario where there's no expectation of privacy. In military use, soldiers are generally very happy to be kept track of, particularly in sensitive areas like the DMZ and the Koreas. So we have the full spectrum of zero tracking, which we've encountered in investment banks in New York City, to full-time tracking all the time. But as far as how to sell this to a union, I would stress it's all about safety. What could be used against a union member that they would be concerned about is perhaps, heaven forfend the idea, but someone that might be slacking off on their job. The system is useless for filing a grievance like that against them if you don't allow access to the history. Real time, though, is very important to save people's lives in real time.
Okay,
so
thank you.
We'll definitely work with, we'll work with any of your unions out there to make sure that it's exactly the privacy that both you and they want. We haven't really seen many issues in the past. It's very tailored to, as we've said, from very little monitoring to the extreme case of all the time.
Okay, thank you for that, Jonathan. What type of training does a lone worker typically go through?
I'll take that one. The design of a well-designed active RFID system entails the lone worker operating a panic button, which in the case of our system requires pressing it 3 times within 5 seconds to avoid false alarms. But other than that, it's all designed into the rules that determine whether something bad has happened or not. For instance, a ladder fall is determined by the following sequence. An accelerometer picks up a few seconds of free fall, followed by a sudden deceleration, and is verified by the altimeter registering the drop in altitude. Believe it or not, the micro altimeters that can be used in personnel badges can detect a drop and the rate of drop over as little as 6 or 8 inches. So there's not a lot of training. As a matter of fact, one of our design philosophies, which is critical, is to take people out of the loop because they can be incapacitated and not able to call for help themselves. That's why we think of this as a guardian angel.
And not only that that people might be incapacitated, but I think one of the main things is during an emergency, some people can have years of training and it just drops out of your mind the second something happens. So that's why we like to try to put everything as automated as possible and as neatly presented to people so they can easily just follow steps, and if they forget everything, it's right there for them.
Okay, thank you. So,
I'm sorry, Mike, if I could just add one final thought on that.
yes.
Our system is designed to be fail-safe so that, let's say somebody falls and it's not picked up by any of the sensors and they're knocked unconscious. Just the very fact that the badge stops moving for X number of minutes, typically 3 to 4 minutes, will trigger an alert with the last known location of the wearer of that badge.
Okay, thank you, Ben. Now, with a lone worker system, once it gets integrated, how will that system work with existing IT and telecommunications infrastructures?
Well, our system is designed with open standards, what we like to call hardware agnostic, and also as far as enterprise resource planning systems, ERPs, we have open interfaces and to all the major ones, and can integrate with, to the extent you would like, with either your ERP, and as far as any mechanical legacy infrastructures such as card readers and so on, we adapt to the vegan standards and the upcoming standards as well. Legacy hardware is not a problem.
Okay, great to know. So in this question, basically it's saying, so Cybra installs a lone worker safety solution. Will that solution be managed internally, or is that outsourced? And how does that work typically? Like when a company typically installs one, is it an internal thing, or is all that outsourced?
Well, as far as the monitoring goes and responding to alerts,
yeah,
that's handled by local emergency services or members of the company themselves. We don't just install a system, mind you, and walk away. We spend a considerable amount of time with every company. It's a different scenario, and make sure you're left with a good, solid set of rules and valid information for your employees. We train the people who will be adding, for example, employees or registering visitors to the building. It's a complete package, but As far as day-to-day management, there's little we can do from our headquarters if something untoward happens 2 or 3 states away. I mean, nobody's everywhere except for our reliable first responders, God bless them.
Okay, thanks again, Ben, for that. And another question, what is the size of the badge that individuals would carry?
It's actually not that large. Figure a credit card, just maybe 4 or 5 credit cards thick.
About 8 millimeters, 9 millimeters, to put it into numbers. It's the standard ISO dimension badge. So if you have current photo IDs, they can be sandwiched together, both dangled on a clip or glued together. There's a number of ways to approach them.
Yes, that is a good point. If you have a current system out there that uses passive RFID and you don't want to replace badges, we can integrate them together.
Okay, great. So is that similar to the system used by many hospitals?
Well, it is the system used by hospitals as far as the passive reader goes. I'm sure you've all seen the black plastic, we call them HID readers, sorry to be using a brand name there, or a props card reader to be more generic, where you just hold it up in front of the reader or touch it to the reader and the door will open. We can approach this 2 ways, by the way, to integrate into those sorts of systems. We can, as I said, sandwich them, or we can add to the inside of our badges a very thin inlay, is what it's called, which is basically the operational guts of one of those props cards, so that it looks nice and neat and is contained entirely within our badge.
Okay, and our last question that I have here, I understand that the movement of staff and equipment is tracked by the Cyber Active RFID system. Can this information be used to A, produce chain of custody reports for high-value items, and B, be used to calculate utilization rates for equipment?
The answer to both of those is a very definite yes. We've had dealings with high-value freight transporters, but many enterprises are very careful with high-cost equipment, and there is an absolute chain of custody created when one of those items is moved, as so long as that high-value equipment has its own tag on it. The personnel badges and proximity are kept track of. As far as utilization rates, the fact that a piece of equipment that's tagged has an accelerometer on it lets you know how many hours a day or a week or a year that piece of equipment has been used, which is invaluable for right-sizing equipment fleets. For example, we were able to save a hospital a tremendous amount of money by keeping track of the utilization rates of their infusion pumps. They found that they were able to do with a third less based on the size that they were maintaining and based on the fact that they would always be able to lay their hands on one within a very few minutes if they knew where they were.
And not only that, but you can also use it for maintenance. If a piece of equipment needs to be checked after every 1,000 hours in use, say, the system can automatically say, once it's hit that utilization, or once it's hit that amount of hours, it can send a message right to your maintenance department to come over and grab this piece of equipment with its location, saying that it needs to be checked.
Very good point, John.
Okay, well, thank you, Jonathan and Ben, for taking part in this Q&A session here. We got a lot of great questions from the audience here, so I want to thank the audience as well for that. I have up on this screen the contact us information. You can get a hold of Ben and Jonathan. We have their email addresses listed there. We also have AIM's information listed as well, so you can either call or email us for more information on AIM. Thanks again, Ben and Jonathan, and thanks again to our audience for their active participation.
Thank you all very much for attending. We appreciate it.
Thank you. Whoops, sorry. Yes, thank you all. It was a pleasure speaking today.
All right, thanks everyone. Have a great rest of your day.